Okay, I'm making a video this morning, and as many of my videos are, this is not going to be a very good video. And there's a reason. There's reasons for that. One reason is I'm just not that good at multitasking. So in making a video here, I have to manage the camera, think of what I'm going to say it, think of what I want to say next, and and then also there's things like I'm talking about something I don't totally fully understand yet. It's in the process of being invented, so I get tripped up there and like I'm not sure how this works. And so, at any rate, there's reasons why the video isn't going to be very good, and I can't really help those. I don't know how to make these better, other than spend lots more time making them, which would help. But why I don't do that is I've made videos in the past, a series where I started out here. You can see I have, let's see, let me move this up here. Had 69 views and then 129 views. That's part one and part two. But by the time I got to part 14, I only have 7 views. But probably most of them is just me, because the way YouTube works, every time I look at it, like I add a comment or something, it adds a view. So I could spend a lot of time on these, but generally nobody's going to watch them. So once again, that's one of the reasons the video isn't going to be very good, is because I can't really justify the time to make it good when nobody's going to watch it anyway. So why make it at all? Well, it's there to be watched if anyone's interested, number one, and number two, it kind of helps me. I can use that to as just a way of organizing my thoughts. So given that, the other thing is when you look at here, when you talk about something, you can talk about what it is, why you're doing it, when things happen, or or where, or how. And so I made now what seems pretty simple, but it's not so simple. It's like, what is gravity? What is time? People still don't know what those are. So the watts could be, when you really dig down. So I tried to do the watts here on my my Padlet. I was checking out what is a UniML, what's the big, what is a comment bubble, what is a bookmark. So there's bookmarks. That's what a bookmark looks like. What is a bookmark? So I tried the watts, but there's a lot of watts there. And then I tried the whys of my video series. Let me go back to here. So in the whys is why do we I went through this thing about why am I doing it this way? Why is this? Why is it that way? Why didn't I do it some other way? So that's not working so well. So I think I'm just going to jump down here to the how. How do you build a UniML model? And then from that we could kind of later on sprout off the what are the things I'm building and why am I doing it, and maybe when and where and all that. So I'm going to shift approach to how. And so the first how is you build a shopping list. So what is a list? Well, people kind of know what a list is, like a grocery list. You say, I want to buy some bacon, and I want to buy some eggs, and I want to buy some bread and some milk. So that's a list. And a list, mathematically, could have things on it twice. You could say milk, like 2 cartons milk. And bread is like 3 loaves you can put in there. Or you could have bacon again in there. That's a valid list. You got bacon twice. It doesn't mean that you're going to buy 2 things of bacon. It just means you forgot that you put it. That means you just forgot it appeared. So when you go into the shopping list, there's your shopping list. And then you have a shopping cart over all that. And so you can take your shopping, when you go through the shopping, you put some bacon in, and then there's the order of this list is, there's 2 orders. The order of creation. Aquinas talks about that. There's the order of creation. And here we have the order of execution. So you might first put bacon in the shopping cart, and then you put the milk in, and then you put the bacon in, and then you put the eggs in. And so this list is unordered, but you could create an order. But you could create an order, and it's just the order you made the list, or the order you executed the list. But there's another order Aquinas talks about, is the order of perfection. In that sense, like the baby comes before the man, but the man is more perfect than the baby. So the order of perfection is the man, the full-grown man or woman, where the order of creation is the baby, then the man, the baby, the child, then the man. So at any rate, so in UniML, what is a shopping list? And the shopping list is of things you might want to make a UniML model on. So it's just a shopping list of things. So, and then the shopping list, you sort of order them. You could think like breakfast food, whatever order you want to do, things like miscellaneous, like conduit, not conduits, like ketchup and all, I forgot what order it is. Condiments, that's what it is, condiments. So you can sort of order your list. So in UniML, there's different, there's this thing called dual spaces. So you have one space and another space, and this dual space symbol means this space 1 is the same as the space 2. For instance, the space 1 might be the Mona Lisa. Here's the Mona Lisa. Space 2 is a list of the pixels, like pixel 1 is X and pixel 2 is Y, pixel 3 is 3. So these are dual spaces. This is a picture of the Mona Lisa. This is a picture of the Mona Lisa. It's just, they're dual spaces. It's just they're in different forms. This is a form of just listing out the pixel values, red, green, and blue. Say this lists a picture of it. And you might have another picture of it. So that's a dual space. This is a picture 1, picture 2. And a dual space doesn't mean they're exactly the same thing. This one might have higher resolution. This might be lower resolution. It might have a color filter on it. But so the idea in UniML, these things aren't, they're structured, but they're not rigorous. There's a little wiggle room in them. And there's a reason for that. The wiggle room is so that you don't have to just, it gives you a little more, you don't have to, it's like speaking legalese. You could just kind of be more informal about it and say, yeah, they're dual spaces. And what exactly does that mean? Well, see, this UniML is to help the human understand something, and the humans are good at things. Humans aren't very good at legalese. The party of the first part will do this for this party of the second part. Humans live in this kind of more mushy round of imprecision. So you want to bring about a bit of precision with a bit of imprecision. So that's what the dual space is. So going to that is, and I forgot where I got onto that. Here is just an icon, or in UniML speak, it's also called a, let's see what I call it. Forgot to, stunt card. A stunt card, it's like in a football game when they spell out "Go Bears." Each people in the bleachers get a card. It might be a red colored card or a black colored card, and they could spell out things like "Go Bears" or whatever. And so I call each one of those cards a stunt card. So a stunt card is an icon. It means the graphics on it, it's all contained. In other words, you might have a symbol like a key. And you could make it bigger or smaller, but you don't really deform it. You're not going to change the key and make it look like this. So these would be dual spaces. That's not a dual space. That's a different key. This is one key, and that's a different key. It just has different one of those. What all these things are. So I call that an icon or a stunt card. A stunt card is, you could have, in a football game, you could have just held up this thing, instead of just this being red, you could have held up and said, here is a block. And then, like you had a diagram here, and you want this block to, you want this arrow between those. You can hold up another block. Where this arrow is not a stunt card, it's a linear feature, because you don't know how long it's, because you might move this block from here to here, or here to there. So the block didn't change. This block is the same as that block. This block is the same as that block. So these are dual spaces. And the pictures are dual spaces, but the line is different. You have to route the line, or you might have run the line like this, or you could have run it like that, or you could have run it like that. So that's called routing. So I'm going to create this thing called a block, and it's a 3D thing because you could stack them. You could have a stack of blocks, or you could have like this. You could have little blocks on big blocks. So, you know, like this big block could be in your grocery list, breakfast foods, and this block could stand for cereal, milk, bacon. And it's a list because you might have late night snack foods. You might also have milk on that. So the milk could be, you got milk here and milk there. It's just, once again, in your list, you could have them things, multiple things. So so you have sort of categories. So that's the first thing in UniML, is you could create a shopping list of stuff that you might want to put in your model. And it's pretty unstructured, and it's not really ordered, other than from a configuration management standpoint. You might order it in the order that you've created it, or such. And then we're going to add this other thing in here, that not only can you stack blocks, but you can create slots in them, which you could put other blocks in. And so in this 3D space we have several relationships. We could have, you could draw the blocks this way too. So you could have over, under, or in. And you use a slot to put something in something. That's in. So that's over, that's under, or on. So this is on this, it's over this and on it. So we're building in our UniML model we went from, if you looked at Dorwood's modal aspects, the block is the numerical aspect, or the quantitative. You could have a block that stands for 2. You could have another block that stands for 2.3. You could have a block that stands for President Biden. You could have another block that stands for President Biden's left hand here. So those are discrete things. And then you can start building kind of structures with them by stacking them and creating slots. And then, so these are spaces. Slots, you can think of spaces, and the box as things. So you have to have a space to put things. So ultimately, your whole UniML diagram is going to be in a huge block with a huge slot. And we might name those later on. So this is kind of the introduction here of the shopping list. And I haven't got to there's other dual spaces here. So this is just one view here. I'm running out of room here. So we could have all these blocks here, and then we could have a dual space where we convert it to some other format, just like we went from picture of Mona Lisa to list of pixels. We have blocks here, and we might have, and then these might be layers, so that you have them stacked, but you could unstack them like this. So here's a stack of blocks. Here's them unstacked. And this stack of blocks, turns out these are dual spaces. They don't have to be dual spaces, but they could be. So I'm building a graphical language here. You can see graphical, I mean, that's graphical, that's graphical. That's textual, hello. I mean, yeah, the H is graphical, and the E is graphical, and the L and O are graphical, but the word is text. So we're going to have in our spaces. So we can have a text. We have text. We could have numbers, which, yeah, you have characters, like 12, that could be thought of as text. But the text stands for numbers, and these other text stands for words. So you have textual things, numerical things, and graphical things. So those could be dual spaces there. Like this is you can think it's textual, but it's also numerical. This is graphical. There's no numbers in this unless she's holding up a sign that says, 12, number 12. Now, but there might be like there's stars, just like there's stars on the side. You might say there's 3 stars, so you could extract from it graphical image, a numerical thing saying there's 3 stars here. So that's another thing you could describe it is we have the Mona Lisa, she has eyes. So that's yet another dual space. Let me go here. Got another dual space we could call feature space. So we have a feature space, we have eyes and ears and nose and hair and teeth and stars in the background. We have a numerical space that maybe it's pixels. We have the graphical space, which is a picture of the Mona Lisa. And we have different versions of that, different pictures, different renderings. We could use shade or one of those processes where you just render it into black and white or outline form. But all these in UniML speak could be linked. They're dual spaces and that they're showing the same thing. They're just showing it in different ways. So that's the how. The what is the Mona Lisa. The how you show it is through different dual spaces. And the why you do that is because each form has its utility, its pluses and minuses. Obviously, this one is easier to understand and see. This one would be good if you want to extract color information or you want to render it with a printer or something. This one, the feature spaces, be good if you're trying to analyze it and recognize it. Is that the Mona Lisa or is that some other smiling lady? And then the different versions of pictures, resolution, there's whatever reason you took the picture. So at any rate, so I've just introduced several key components in UniML, the dual space arrows, the blocks, slots, and how they relate, and what you use them for. The why is a shopping list. The shopping list is just things you might want to make a model of. And so let me go back to here. I'm almost done here. Where is this? Where's my model here? There we go. So when you look here, you don't see any of those blocks because I'm showing other dual spaces. I don't think I even got around to making that here. I've done that on earlier videos and other things. So that's the thing. There's a lot of things here. So like when you look at this and say, where are the blocks in this diagram? It's like, oh, I hadn't got around to putting those in here yet. And the reason is it takes a long time to make this, where this one is essentially, it only takes me the time to talk the video. And like this is a bad video. Here I have more structured videos like here. And I spent a whole day probably, or maybe 2 days making one of these. And I already explained what. So here, this is a dual space. This is just my chaotic dual space where it could end up being more formalized like this or even made into a video. But it's the same information, just formatted different ways. So I'm starting here and I could probably use this to, if people watch this and say, oh, that's pretty interesting, then I might think, oh, well, then maybe I'll take this and convert it to more like this. Let's just, I'll just open that up. You can see I have all these structures here. And like, now, what you could think is this is a layer, and under that layer, there might have been these other dual spaces that showed something more like this. It's because this is just one layer of a stack. So these stacks, you could kind of think of them as layers. or levels. I never can figure out which one it is, or levels, layers, or strata. And you can kind of, so what you're really going is from 3D to 2D. That is a 2D drawing. This is a 2D drawing, but it's representing a 3D structure. So, and then actually, if you have like a video, you can think of it as a 4D structure because you have time and frames and stuff. So anyway, let me end the video here and pick it up later. And I don't expect many views or any views, but I think I'll continue this even if I don't get many views, because who knows, maybe I'll get them later on. So anyway, have a good day.